What's up, everybody? Welcome to Electrician's Masterclass, where knowledge is power. I'm your virtual New Jersey electrical license prep course instructor, and you can find us at electriciansmasterclass.com. All right, so today what we're talking about is a improper service upgrade. All right, and I'm going to tell you what I think they did and the things that have to be done to fix the problem. All right, and the codes that apply to that problem. Okay, so let's get into it. Okay, so what I think they did over here, okay, is that this was, it looks like to me that it was a 100 amp service originally, okay, from the original house. It looks like it was done like 3 times already, okay. So the first service was 100 amps, okay, and I'll tell you why in a couple of minutes, why I think that. All right. Now, I think this was the second time that they put, actually, it looks like it might have been even the third time, because as you can see, there's a very old 2-inch pipe coming in the side here. All right. So I think the service was there originally. All right, after the 100 amp service, they put in a 200 amp service. All right, and then maybe the panel wasn't big enough. All right, because this looks like a fairly new panel, and I think they changed it a third time. But when they did change it the third time, they decided to do this. Okay, as you can see, there's all airspace around the 2-inch pipe over here. This is a heavy wall rigid pipe, and you can see the airspace around the 2-inch pipe. Okay, the pipe is going right through the panel. Okay, so let me tell you a couple of things what that can do. Okay, besides losing continuity. All right, you're going to have a little bit of it, but it's not going to give you a good bond, a good ground. All right. So it says if an electrical conduit or pipe enters an electrical panel without a proper connector, it typically indicates a violation of the National Electrical Code, NEC, and here's why. All right. So the first one would be lack of secure connection. Without a connector, the conduit is not properly secured to the panel, which could lead to movement, damage to wire, and possible disconnections. All right. And then sharp edges and wire damage. The edge of the hole in the panel may be sharp, and without a connector, it could damage the insulation of the wires, increasing the risk of shorts or electrical faults. All right. And then, of course, there's a code violation. NEC requires that all conduits be properly terminated with listed fittings to ensure safety and compliance. Everything always has to be listed. You can't just slap a pipe right in the side of the panel with no connector, because there's no bond, there's no connection, there's no ground. You know what I'm saying? And then the grounding and bonding issues. Certain conduit types, like metal conduit, also serve as a grounding path. Without a proper connector, grounding continuity could be compromised. So right here you have a problem. There's no connector here. Should have been cut. It should have been gone into like it was a threaded pipe, so the nipple should be long enough with the thread that went in with a lock nut on one side over here, a lock nut on the other side over here, and then the bushing. Okay, not straight through the panel, like almost to the middle where the breaker is. That's so illegal. Okay, so when it's a main panel, what do we bond? We bond the neutral. We don't separate the grounds and the neutral, okay? So what's going on over here is the grounds are, even though it's touching the back here like this, it shouldn't be set up like this. These grounds should be inside the neutral bar, okay? And if they're not, maybe it's because he didn't have enough room. But as we look at the other pictures, it seemed like he did have enough room. So what he did was he did not bond his panel. All right. So let's let's continue. Okay, so here's a couple of code references, NEC 2023 code references. So the first one is going to be NEC 300-10, and that's going to be electrical continuity of raceways and enclosures. Okay, so you can see that it's not, connected to the panel, right? Okay, it requires raceways, conduits to be installed to ensure electrical continuity and prevent mechanical damage without a proper connector. The conduit may not be secure, violating this requirement. Okay, and then we have NEC 300.12, which is mechanical continuity, raceways and cables, and this states that raceways must be continuous between termination points. A missing connector may create a discontinuity or weak mechanical connection, which I was saying in the beginning. All right, and then there's another code, NEC 300.15. So it violates a lot of different codes. All right, so it's saying boxes, conduit bodies, or fittings where required. All right, it requires that raceways be properly terminated with an approved fitting to prevent damage to conductors and ensure a secure connection. So it definitely needed a connector. Okay. So that's metal. So like I said, you'd have to put the lock nut on the outside. You'd have to put the lock nut on the inside. All right. And then you'd have to put bonding bushing. All right. If you're going to still continue to use the metal. Provided that it is not a concentric knockout. Okay. So if it was popped out of the side, then that's the way you can do it. All right. Then we have NEC 314.17, which is conductors entering boxes. Conductors entering boxes, conduit bodies, or fittings. All right. That specifically states that where cables or raceways enter boxes, they must be secured with an approved fitting or connector. This prevents wire insulation damage and ensures mechanical support. All right. Then we have NEC 110.3, which is the installation and use of equipment. This requires that listed and labeled equipment, including conduit connectors, be installed per manufacturer instructions, which typically mandate the use of connectors for proper conduit termination. All right. So everything is leading to this needs a connector. All right. Then NEC 110.12, electrical equipment, mechanical execution of work, requires electrical equipment to be installed in a neat and workmanlike manner. Running conduit into a panel without a connector would be considered improper workmanship. Now this panel was installed. I guarantee this panel was installed without a permit. Okay. And either somebody said they knew what the heck they were doing, or it was an electrician who didn't even know what he was doing, okay? And he wasn't licensed, all right? He might have worked for somebody or whatever, but I'll tell you right now, electricians know the codes, and this would have never happened if there was an electrician installing that panel, because he would have did it the right way, all right? So now, another problem in that panel, as you can see, there's still a lot of spaces over here open for the grounds that could have been put in there. You know what I'm saying? They're all open over here. So he could have put these grounds into this neutral bar, okay, and eliminated this, because this is not a sub panel. The only way that you would do this is if it was a sub panel. Then you would have one wire for the ground, two wires for the hots, your lines, and one wire for the neutral. All right. Over here, we're bonding the ground to the neutral, okay? So this is not a sub panel, this is a main panel. And as you can see this little red circle, you could see that he did not bond it, okay? And if electricians should notice right away, once you take that panel out of the cardboard box, that green ground screw goes in there if it's a main panel. That's the first thing that you do when you set it up, okay? So the ground and neutral will not be properly bonded because of this, because it's not going through the bar into the back of the panel, so it's not bonding everything, okay? In the main panel, the neutral grounded conductor must be bonded to the grounding system to ensure a proper return path for fault currents. Without the green bonding screw or jumper, the neutral and the ground remain isolated, which can cause improper operation of breakers. They may not trip properly during a fault. Higher risk of electrical shock if a fault occurs and there is no effective path to ground. All right. Voltage issues between neutral and ground, leading to stray voltage issues. All right. So it's not a good thing. All right. It also could cause a potential shock hazard on metal parts. If a fault occurs, a live wire touches a metal enclosure, okay? The unbonded panel may not clear the fault properly. Instead of tripping the breaker, metal parts could remain energized, leading to electrocution risk for anyone touching the panel, damage to connected appliances due to unexpected voltage fluctuations, all right? Number 3, NEC code violation. The National Electrical Code, NEC 250.24A5, requires that the neutral bus be bonded to the grounding system in the main service panel. This ensures that fault currents safely return to the utility transformer and trip the breaker instead of lingering in the system. All right, another thing is an ineffective surge protection. Many surge protection devices rely on a properly bonded ground and neutral. Without the bond, surges may not be properly diverted to ground, increasing the risk of equipment damage. All right. Ground faults may not clear properly. A missing bond screw can prevent ground faults from returning to the transformer efficiently. This can result in breakers failing to trip, which we said before, allowing hazardous conditions to persist. So in the main panel only, install the manufacturer supplied green bonding screw or bonding strap sometimes, okay, to connect the neutral bus to the panel's grounding system. In sub-panels, do not install the bonding screw. Neutral and ground must remain separate beyond the main panel. And we talked about that just a couple of seconds ago. Okay. So this is where that ground screw goes. All right. So if you notice, it's like right next to the last lug. There's like, it's right next to, it looks like the neutral lug. It's right next to the neutral lug, obviously, because it's the ground bar, obviously. And you see this green ground screw goes right through this bar, right through the plastic, right through the back of the box, bonding everything, okay? And that's the way it should be done, all right? All right, now another thing I found with this service was whoever did the stucco, came into this stucco, never secured the pipe to the house, okay? So when you get these crazy windstorms, it's going to be pulling on the pipe. It's going to be pulling on your service wires. All right, there's no more drip loop, so the water is not going to drip down anymore, okay, because that loop, it settles at the bottom of the loop and then it drips down, okay? So if it doesn't do that, the water stays on the wires, okay, which could corrode the wires, which could make them crack, which could make them arc, which could make them go on fire, all right? So over here, as you can see, this was pulled. All right, and it was pulled towards the front of the house. So it says, if electrical service conduit, the pipe that protects the electrical service wires entering the house, is not securely attached to the house, several dangers can arise. All right. So one is the physical damage to conductors. Without proper support, the conductor can shift, sag, or pull on the electrical wires inside or outside. Over time, this can cause wire insulation damage from the movement or exposure to sharp edges, breakage of conductors leading to power loss or a fire hazard, okay? So now this, because it pulled the pipe, it pulled the point of connection right here. where it gets tied onto. All right, it pulled it right out of the house. All right. So when I come there, what I have to do is I have to put, because now it's not long enough, the cable's not long enough, obviously. All right, so what I have to do is I have to temporarily put a hook in there and get some rope and temporarily tie this until the utility company comes. All right, and then they bring a new wire from the pole, but that's a whole to do because you have to call it in and everything, and it has to be arranged. All right, so because of this, you can see that all the bugs are next to each other. So if some of this tape comes off and they happen to touch, there's the arcing, and it's going to cause a fire right there. You're done. Okay. So increased risk of weather exposure. A loose service conduit may expose electrical connections and wires to water, moisture, or debris, potentially leading to corrosion of wires and connections, short circuits, or electrical arcing due to water intrusion. All right. And the failure of the electrical systems during storms or heavy rain. All right. You get a lot of snow, and that's going to weigh that thing down. So there's going to be problems, you know. So it's a very dangerous situation. Okay, so now as you can see, all that water is just dripping down on this meter. Okay, well, they did put a smart meter in there, so that was one good thing. But that was public service. It had nothing to do with what the electrician did before that, or if he was an electrician. All right. Okay, so what happens is all the water doesn't drip down anymore, and it settles on the wire, and it drips down the pipe. It starts to corrode and rust the pipe, and then all of a sudden it could get into your meter box. It could drip into your meter box. It could settle in your meter box. It could go down the pipe, which eventually will go right into the panel, and now you might have water in your water meter. Okay, which you can see it's starting to get all rusted and everything, and corroded and everything. And you could have problems in the panel if the water gets in there. Okay, so the strain on the meter base in the panel. The conduit is supposed to relieve strain from the wires in the electrical meter or service panel. If it is not secured, movement can loosen the meter base or cause cracking. Pull on the connections inside the meter or panel, creating a fire or shock hazard. So what it's saying is, like, as this all pulls towards the front of the house with the pipe and everything, it causes a lot of problems, all right, which could cause a fire. Okay, so now here's another problem that they had in here. All right, this was just, I came in and I said, this whole thing's got to be changed, all right? We put PVC pipe in there. We put a new panel in there with a connector, okay? And I can tell this was not an electrician, or this was somebody that didn't know what they were doing, because when they changed the 200 amp service the first time, okay, they did not use the proper ground, okay? So that would be in grounding, all right? 250.66, all right, grounding electrode conductors, okay? And it will tell you the size that is necessary for a 200 amp service. And it says upgrading electrical service from 100 amps to 200 amps without properly upgrading the grounding electrode conductor can create significant safety and compliance issues. The grounding system is critical for safety, dissipating fault currents and stabilizing voltage. Here are the dangers of not upgrading the grounding electrode conductor. This was the number 8, which is good for a 100 amp service, okay, which it originally was, all right? But when they changed it the first time, this should have been changed, okay? So I eventually changed this to a number 4, copper, all right? Because that's what, put new clamps on there, and, I used a sandpaper a little bit, and, just cleaned it off a little bit so it was a good connection, all right? But I changed it to a number 4, which is what a 200 amp service requires, okay? So here's some of the things that could be a problem. All right, let me get that back over here. All right. So the first thing is inadequate fault current carrying capacity. All right, the grounding electrode conductor must be sized to handle the increased fault current potential of a 200 amp service. If the grounding electrode conductor is undersized, it may overheat or fail during a fault, increasing the risk of fire. Fault current may not properly return to ground, leading to equipment damage or prolonged fault condition, which we said before, right? And then the violation of NEC code requirements. All right, NEC 250.66, which we were just talking about, all right, specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. For example, a 100 amp service typically requires number 8 AWG copper grounding electrode conductor for certain electrode types, which you've seen. That was what was originally there. So when they changed it to 200, all right, because you've seen they put in a 2-inch pipe, all right, and they put, they put in what they were supposed to put in for 200 amp service, right? But they never changed the grounding electrode conductor, all right? So 100 amp service, like we said, requires a number 8. A 200 amp service typically requires a number 4, which I told you that we changed it to, all right? Or larger depending on the type of grounding electrode, okay? We use the number 4, copper. Using an undersized grounding electrode conductor is a code violation and may result in inspection failure or liability in case of an incident. All right. Okay, so it can also cause poor lighting and surge protection. All right. We talked about surge protection before. An undersized grounding electrode conductor may be unable to properly dissipate high energy surges from lightning or utility switching, increasing the risk of damage to electrical equipment and electrical fires. All right. And then 4, the grounding electrode conductor is a key component of the overall grounding system. All right. If it is too small, it may not establish an effective connection with the grounding electrode. Which is a ground rod, a water pipe, or a UFA ground, all right? So in this case, it's the water pipe, all right? And then it says voltage imbalances could occur in the system, leading to the electrical shocks or unreliable operation of appliances. Then we talked about the electrocution again, okay? Increased risk of electrocution. A smaller grounding electrode conductor may not provide an effective low impedance path for ground fault currents. This could cause exposed metal parts of electrical equipment to become energized, increase the risk of shock or electrocution for anyone in contact with the equipment, all right? And long-term wear on the equipment. Improper grounding can result in electromagnetic interference or poor system performance, causing premature wear or failure of sensitive electronic devices, okay? So what happened was, as you can see, we had to put, this became a sub-panel. The original panel became a sub-panel, so that's where we had to put the ground bar in, okay, because now it's not a main panel. This is the main disconnect, all right? And it's a 200 amp disconnect. All right. And as you can see, everything's properly grounded. We came up with PVC. All right. And then, like I said, the utility company came, they put a new wire in, a longer wire, and now they have a drip loop and everything up on the top. All right. I'm not showing you that because it wasn't completed at the time, but this is when it was completed. All right. And you can see that we have our interbond grounding our all our stuff from our like cable and telephone and all that stuff, and which you are allowed to do that also went to the main disconnect, and we went through that, and then we went through it, and we also came down, and this was our ground for our 2 ground runs, where we go to the 1 ground rod, and then 6 feet away we put another ground rod. Okay, so that's the correct way to do it. So that, like I said, became a sub panel. This is your main on the outside. This is your main now. That needs the bonding screw, which is the green screw. All right. So don't get confused. If you have any questions, hit me up. Let me know. Click like and subscribe, and I'll see you guys and girls on the next one.